What is a Better Predictor project, we asked ourselves the question, what is a better predictor of the cost of a used car? Number of miles or age? To answer this question, we first made our own prediction. We predicted that the mileage of the car will determine the price of the car more accurately than the age. Mainly, we base this prediction off of our assumption that older cars we see on the roads must run because of their low mileage. To find out if our prediction was true, we conducted statistical calculations that would lead us to the answer of our driving question. Now let's explain our process.
Our two explanatory variables are number of miles on the car and the age of the car. Our response variable is the average price of a used car. These three variables are used throughout our calculations.
Here is the data we collected. All of our statistics came directly from Edmunds.com. We first decided to choose the cars by selecting 5 different brands of cars. We then selected a matching car with the same brand, just a year or two younger or older than the first car chosen. On the first chart, we took different car types and compared their gas mileage to their cost. On the second chart, we compared the same car's age to the cost.
The first graph displays the relationship between age and price of the cars and has a strong negative correlation with an R-squared value of 0.53. Moving forward, the second graph displays the relationship between age and mileage of the cars with, once again, a strong negative correlation with an R-squared value of 0.58. Both graphs display a strong linear pattern.
The residual plots show us no specific pattern, which tell us that the graph will be linear. The numerical summary can show us the similarities and differences from the scatter plots. As we've previously said, both graphs have a negative correlation. The equation for the mileage of car graph was price hat equals negative 265 miles plus 3.7e plus 4. This equation provided us with a standard deviation of 30.56 and the R-squared value of 0.58. The equation for age of car graph was price hat equals negative 2.83 age plus 3e plus 4.1e plus 4. The standard deviation from this formula is 2.75 and the R-squared value is 0.53.
Our data has finally led us to a conclusion. The number of miles is a better predictor of the price of a used car. Both of our explanatory variables were similar to each other. The correlation between mileage and the price was slightly higher than the correlation of the age and the price. For the age, 53% of the data was accounted for, whereas the mileage, 58% of the data is accounted for. The fact that more data was piled on the positive side of the horizontal line for mileage in our residual plot allows us to conclude that our prediction was right.